And welcome. Transformation, a geometric transformation, is just the change in the location, size, or orientation of a figure. And we've seen a lot of our transformations already when we were dealing with congruent triangles, but now we're actually going to be talking about the specific types of transformations that we see. Translations is one of them, and that's going to be our first that we're going to be emphasizing today. We have reflections, we have rotations, we have dilations, and compositions that we'll be getting into later this unit. Some important vocab for Unit 7. The pre-image is the original image before any type of transformation happens. And then our image is our new figure after some sort of transformation has occurred. Isometry is when the pre-image is congruent to the image, right? We've seen that a lot, right? Meaning, both of those things, those triangles are congruent to each other. It's where we have our length and our angle measures the same, right? Those corresponding angles and sides. We also will deal with something called prime notation, which means on our pre-image, we have just that uppercase letter. And then on our image, we'll have that uppercase letter, but then we'll have this prime on it, right? That prime, that new and improved vertice. This apostrophe just means prime. And sometimes we'll see a single prime, sometimes we'll see a double prime, and that just means that figure is the newer one, right? The more primes, the newer the figure is. And then we also have vector notation, which is called considered component form. So when we have our two numbers, and in this case, I'm writing them as vertices with these arrow brackets. A represents the horizontal move, and then B represents the vertical shift. So something we'll see, right, taking that ordered pair, right, this pre-image, this information that x minus 2, y plus 1 is our new and improved image, and this is the shift we make to that pre-image. We can write this form in vector form by just writing out the shifts that we make horizontally and vertically with those arrow brackets, right? We have our arrow brackets versus our parentheses. All right, next up, I'm writing my rule for my translation from my triangle CUB, my pre-image to my image of C prime, U prime, B prime. So looking at the pre-image and then the image, there's no shift, there's no rotation, there's no change in orientation. We're simply just taking that figure, the initial, and moving it. To figure out how we're moving it, we're just picking two vertices. How about U prime? I'll go to the left, 1, 2, 3, 4, 5, 6, and then up, positive 9. When I'm creating that rule, I'll write out my ordered pair first, my pre-image ordered pair, and the changes I'm making to that ordered pair. I'm subtracting 6 from the x, I'm adding 9 to the y. Doing the same thing for my others, right? Going to the left, 6, and then up 9. And that is that beautiful translation. Back to one without a visual. We're following this translation rule, given that ordered pair, and we're going to be making some shifts to it. So given my image of 2, 7, I want to make some changes, meaning add 4 to the x and subtract 7 to the y. So my image, my new and improved, will be 2 plus 4, which is 6, and then y, meaning 7 minus 7, which is 0. My pre-image of b prime, here I'm given b prime, and I want to figure out what the b is. So I need to do that reverse rule. So instead of adding 4, right, because I'm going back to find my pre-image, I'm going to subtract 4. So 2 minus 4 is negative 2. And then 7 plus 7 is 14. The reason I'm doing that is because then now when I'm using my rule on my pre-image, my b, that rule works to find my actual image. So if I were to do negative 2 then plus 4, I get my positive 2 in b prime. 14 minus 7, I get my positive 7 in that b prime. All right, go ahead and draw this one out. Draw out your vertices dog, and then create your image of that pre-image of dog. So at the end of the day, you should have your triangle dog drawn, and you should have your triangle D prime, O prime, G prime drawn. And you should have these two triangles graphed. I always like to write out what I'm doing right with that translation. You don't have to. I just like visually seeing the math speak to the what we would speak it out. All right, and go ahead and try 6. We're given the image and we're asked to find the pre-image vertices. And then for that last one, that try 6, we are using or we're finding the pre-image. So we want to use the opposite of that rule. So instead of x minus 2, y plus 6, because we're working backwards, we're going to add 2, and we're going to subtract 6 to find those initial values.